So today, as we continue on in lesson 4.6, we're going to move into the graphing part. So a linear equation solved for y, as they were in yesterday's exploration. Actually, that would have been last Friday when we were here. When it's solved for y, it's considered to be in slope-intercept form. And when I ask you to tell me what slope-intercept form is, you should be able to recite that y equals mx plus b equation. Just like we know that standard form is what?
ax plus
b, y equals c. Yeah, so we should be able to tuck between those two forms. We have a standard form, we have a slope-intercept form, and remember they both represent the same equation, they just look different is all. So in our slope-intercept form, what is the m representing again? This is just quick review. Slope, okay? And b is the what? The y-intercept. Well, after we put that slope in for m and we put that y-intercept in for b, we still have an x and a y there. So the x and the y that are in that equation can represent any ordered pair that would be on that line, any solution to that equation. And a solution is basically any ordered pair that makes that equation true. So if you know the slope and the y-intercept of a line, you can easily graph it. In fact, it's the best form to have it in if you're going to graph it. So graph the line whose slope is 2 and the y-intercept is -3. I say here, start by plotting the y-intercept at ordered pair, 0, -3. So we go to the y-axis, and we're going to put a point at 0, -3. We know that line is going to cross the y-axis there. Well, knowing that the slope is 2, that means we should be able to, because remember, between any 2 points on that line, it has a constant rate of change, that slope. So we should be able to create tons more points just using the slope. I'm going to require you to have at least 3 points on your graphs for a line, okay, when we're using slope-intercept form. So the y-intercept is one of them, and we're going to use the slope to make at least 2 more. You can make as many as you want, but you have to have a minimum of 3 points on your graphs. So when the slope is 2, what's the rise and what's the run? 2. The rise is 2 and the run is 1, because we can put any number that's not in fraction form over 1, so we have a rise of 2 and a run of 1, meaning we can go up 2 and 1 to the right. But we can also go the other direction. Why can we also say the rise is -2 and the run is -1? It's still a positive 2, isn't it? Because a -2 over a -1, a -2 divided by a -1 is still a positive 2. So we can use both of those. And typically that's what I would want you to do. So let's use the positive 2 over positive 1 to make our next point. Up 2, 1 to the right. Going up is positive rise, going right is positive run. And then let's also use our other name for our slope, our -2. So we're going to go back to the y-intercept, and we're going to go down 2 and 1 to the left. And we could keep making points forever using that slope. But what did I say you have to have? What's the minimum? 3 points. Okay, go ahead and draw your line. Right through those points, go all the way through the coordinate plane. Don't just go through those 3 points and put little arrows at the end. Draw it all the way through your graph. Like that. All the way through. And then you can stick your arrows at both ends. Showing that that line really does go on forever and ever. How many points does this line have? An infinite number. We only graphed 3 of them, but there's a whole bunch more on them, right? How many points would be in the table for this equation? Just 3? If there's an infinite number of points on this line, guess what, folks? There's an infinite number of x and y's together in a table also. every point that is on this line also has a place in the table. So the table, the graph, the equation, they're all related. They all belong together. Okay? So tell me right now 3 points that we know for sure are in this table. The table for this equation.
0.
Abby, what's one?
1, -1.
1, -1. Okay, so 1, -1, that's our one right here. Okay, what's another ordered pair that would be on our table, Jared?
-1, -5.
-1, -5, that's this one right here. What other point would be in our table, for sure, Courtney? 0, -3. And we could find lots more of them, right? In other words, as the y value changes by a +2, the x value changes by a +1. Or we could say it this way. As the y value changes by a -2, the x value changes by a -1. So even without looking at this line, we could actually still create a whole bunch of ordered pairs for our table. Okay, now, you do not have to do this in your homework. You do have to write the equation of the line, if it wasn't given to you. But I'm not going to make you check 3 points from the line, but I want us to check and make sure they make the equation true. I want you to understand that they're really solutions for this equation. So what is the equation of this line? If it has a slope of 2 and a y-intercept of -3, Jared?
Y equals 2x minus 3.
Yeah, this is what we did for today. We wrote the equation, substituting the slope in for m, the y-intercept in for b, cleaning it up. This is cleaned up already. Okay, so now what we're going to do is we're going to check those 3 points that you guys said would be in the table. Okay, so let's start with, so here's our equation, y equals 2x minus 3. Let's start with the first one, the one that Abby gave us. What was it again, Abby?
1,
1, -1. So we're going to substitute in for y, we're going to put -1. In for x, we're going to put +1. We're just checking to make sure that this ordered pair really does satisfy this equation. It really does make it true. Okay, so -1 equals 2, take away 3. We're not solving, we're substituting in and making sure we get a true statement. -1 is still on the left. What is 2 take away 3?
-1.
-1. That one checks out. Okay. Now we're going to check out what was another one that we said is in that table.
0.
0, -3. Okay, let's check out 0, -3. What's going in for y? -3. What's going in for x? 0. 2 times 0 is? 0. Bring our -3 down, and what is 0 take away 3? -3. Checks out. Okay, you check out that last ordered pair. What is it again?
-1, -5.
Okay, -1, -5. Check it out, make sure it makes that equation true. And many times when students are checking problems, this is where they would stop, where I'm at right now. They say, done, it works. It's not done yet. The right side is still not simplified. What is -2 take away 3? -5. Because it is or because we want it to be? Because it is. Okay. So all 3 of those points actually check out. Now again, I said you're not going to have to do the check problems in your homework, but I want you to understand that any points on that line, if it truly is the correct graph or an equation, it better make the equation true. And vice versa. You had to write your own equation here, so you graph it using the y-intercept and the slope, and you get your graph, and then you write an equation. Okay, what if you wrote the wrong equation? Your graph might be right, but you still might write the wrong equation. So again, any points on that line also have to, if you had to write the equation, they better make your equation true then. If they don't make their equation true, something's wrong. Either your graph is wrong or your equation is wrong. Something's gone wrong in this situation. Any questions? Okay, let's go to the back side. And they give us the equation. Graph the line for the equation. Y equals negative 1/4 x subtract 4. Well, I typically, the first one I typically identify as the y-intercept because it's usually the first, it is the point you start with. So what is the y-intercept for this one?
0, -4.
It is 0, -4, or in other words, b is -4. So that means we're going to go to 0, -4 on the graph, and that'll be our starting point. So 0, -4. Now here's what happens when students are graphing. When we're doing slope, remember slope is rise over run. We deal with going up or down first, and then we go left or right. But when we're graphing ordered pairs, we do the opposite. We go left or right first, we go to the x value first, and then we go to the y. So you have to keep the two straight. You can't let this mess you up. What is the slope for this one? What's the slope? -1/4. Okay, now I want you to get in this habit. I want you to get in the habit of writing what are the two ways you can actually do the rise over the run. If this is a -1/4 slope, remember on the front we did that with the +2 slope. We had two ways we could do it. We went up 2, right 1. We went down 2, left 1. What can we do here? We can go down 1, so we make the 1 negative, and we can, if we make the 1 negative, are we going to go left then 4 or right 4? If it's a -1/4, we've used it the negative going down, could we go negative again? What's a negative over a negative, class? Positive. We've already used it for a negative. We want this slope to stay negative. We can't go in the negative direction again, so we have to treat the run as a positive for it. Or we can go up 1, not use up the negative for the rise, but then if we go up 1, what are we going to do for the run? Go left 4. We're going to have to use the negative for the run. Okay, go ahead and graph 2 points using both of those names for slope. Yeah, I need that one. So, do you have a question? Yeah. Okay, what is it? Up one is, because look at what's happening right now. It's rising from left to right, and it's a negative slope, it should be falling, right? And remember what I said about, we always want to check it out. If we have a negative slope, we know what the behavior of the line should be, don't we? What should it be? If it's a negative slope, how should its behavior? It should be falling from left to right. So if after you're done graphing this, they're not falling from left to right, I think there's a problem, right? So that's why we're going to keep that in mind. Okay, so there's our line. Questions, concerns? Remember, I'm not going to make you do the checkpoints. Okay, then let's do one more. Graph the line for the equation 3x minus 2y equals -15 using the y-intercept and the slope. What form is this? This is a standard form. What method have we used with standard form? When we left it in standard form, what did we find then? So what?
X and Y points on the graph.
The x and the y intercept, so we graphed it that way with those 2 points. So this is saying it doesn't want you to use the x and y intercept, it wants you to use the y intercept and the slope. So what's the first thing we're going to have to do?
Add two.
Get this in slope intercept form. That's going to be our first move. So let's get it in slope intercept form. I'm going to first change it to add the opposite so that I'm more successful, because I find students are terribly unsuccessful at putting in the slope intercept form because of subtraction. So change it to add the opposite before you start. And what would be our first move here? Subtract 3x. So now we have a negative 2y equal to negative 15, and I'm going to make that plus a negative 3x. What's our next move?
Divide by -2.
Divide every piece by negative 2. So negative 2y gets divided by negative 2. Negative 15 gets divided by negative 2. Negative 3x gets divided by negative 2. Kind of ugly. Only one even number up there to divide into. So what's our equation? What does it become? Y equals
7.5 plus 3 over 2x.
7.5 or 7.5 plus, remember what we said, we're not going to change that to a decimal. We're going to leave slope as a fraction because then it's graphic friendly. We have a rise and we have a run. Okay. And again, remember, this can also be rewritten. Let the x's be first and the y-intercept follow. So what is our slope and what is our y-intercept? Remember, I tend to claim the b value first. So where are we going to start on the graph? 7.5, which is ordered pair 0, 7.5. Now, don't let that throw you off. It's okay that we have to start halfway between. So let's just go graph that. So 0, 7.5. So we'll go up 6, 7, halfway between, and I can't do it very well on here, but halfway between 7 and 8 at 7.5. Okay, and what's our slope? 3 over 2. Or, what's another way to do it? Yeah, negative 3 over negative 2. Well, what happens when we try to use slope in the first form? Positive 3 over positive 2. It goes off our grid, doesn't it? We could make the grid bigger so that it would fit, but that's too much work. What can we do instead? Make 2 points with the other one. So we'll go down 3 and 2 to the left. Okay, so we'll go down 3, but now when you're going down, you're going to have to go like, the halfways between. So you have to go to 6.5, down to 5.5, down to 4.5, and then you'll go over 2, and you'll be there. So you'll be at ordered pair negative 2, 4.5. And then from there, you'll do that again. You'll go down 3 and over 2, and now you'll be at ordered pair negative 4, 1.5. And you will draw your line going through the points and ask yourself, that's not a very good line, but, and ask yourself, do I have good behavior for my line? Yeah, it's got a positive slope. I'm expecting it to rise from left to right then. The only thing would be, or could go wrong, is when you're putting it in slope-intercept form. If you did not put it in slope-intercept form correctly, you might have ended up with a positive slope, a negative slope, and then you would have said, well, it should be falling then from left to right. So we also have to be really careful about making sure we get the equation renamed properly. So any questions at this time?